Alright, so let me go over version B of the Chapter 2 test for pre-calc. For question number 1, I'll tell you what I do for my creating of my tests. For both versions, I use the same choices. I just change the graph to match one of the choices. Here I have x equals a negative 1. And here I have x is equal to, wait, that's positive 1. And that's a positive 3. So x equals 1. Notice how it goes through. So that's a shoot through, which means I know that it's going to be odd. Okay? And then means the multiplicity, I can have any odd multiplicity. 1, 3, 5, 7. Here at x equals 3, I notice that it touches or kisses. So that means that it's an even multiplicity. Something like 2. So that would be letter choice A. Notice it has multiplicity of 1. And then at 3, x equals 3, its multiplicity is 2. Okay. Question number 2, probably the harder question. For question number 2, it says find a polynomial of degree 3 whose zeros are negative 3, 3 halves, and 2. So here's a common mistake. This is how you know if you are successful in this whole chapter test. If when you take x equals 2, you're putting into the binomial x minus 2. Okay, the reason for that is if you subtract 2 from both sides, you have x minus 2 equals 0. That's what goes into the binomial. Negative 3 is really x plus 3. X equals 3 halves. Well, if you set x minus 3 halves equals to 0 and multiply by 2 on both sides, you're going to get a 2x. 2 times negative 3 halves is minus 3. So x minus 3 halves is the same thing as 2x minus 3. If you're paying attention, you'd recognize that, well, I need to get this in standard form. I need to multiply all of this. Sorry. So the first thing I did is I multiplied x plus 3 times 2x plus 3, or 2x minus 3. Use FOIL or the box, and you'll get 2x squared plus 3x minus 9. I take the trinomial and multiply it by the binomial. There I have a negative x squared, negative 15x, and a positive 18. That is choice D is your correct answer. Question number 3. Which of the following is a polynomial with real coefficients that has 2? So I'm going to put a box around that. That's one solution. And then 2 minus I is another 0. So right now they've only given me 2. But remember, complex conjugates come in pairs. So 2 minus I, you should have had also 2 plus I. Well, what do you do with those? You put them into binomials. You write x minus on all of these, x minus, and then you just take that value and put it in here. So I have 2 minus I, 2 plus I, and the 2 there. When you distribute here, this becomes x minus 2I and plus I. And over here, this becomes x minus 2 plus I. So if you recognize in the problem, in the multiple choice here, all of your choices have either an x plus 2 or x minus 2, so I don't really need to distribute this. All I have to do is just multiply these two. To do that, I just multiply. I took 1, put it on the side, put it on the side there. X times x is x squared, negative 2x, negative ix. Negative 2 times x is negative 2x, positive 4, positive 2i, ix, negative 2i, negative I squared. Remember, negative I squared is equal to negative 1, and you have that negative 1, so that becomes a positive. So you'll have x squared minus 4x plus 4 plus 1, add the constants together and gives you the 5. Your letter choice is D is your correct answer. Question number 4. 9 plus 3i over 3 minus 4i. The answer is C. Show you why. I take the denominator and I have to find its conjugate. The conjugate is changing the minus sign to a plus sign. I'm going to do FOIL or the box, or FOIL in the box. So 9 plus 3i times 3 plus 4i. I get 27. That should be a 9i, and that's 36i, and that becomes 12i squared. There's negative 1, so that becomes negative 12. Combine like terms, I get 15 plus 45i. Over here, 3 minus I and 3 plus 4i, that's a negative 1. So that becomes a plus 16. They cancel. 9 plus 16 gives me 25. Then I can just split up the fraction, 15 over 25 and 45i over 25. You just reduce and you'll get 3/5 and 9/5 I is your correct answer. So there's my reducing over here. I just turn them into factors and then cancel. Question number 5. For question number 5, negative 4x squared. For question number 5, I'm going to take my last term, which is 6, and that'll be my factors of 6. And then here, it does not matter that it's positive or negative, that becomes my denominator. Factors of 6, 1 times 6, 2 times 3 equals 6. 4, 2 times 2 or 1 times 4. Then you're just going to make all of your possibilities 1 over 1, 2 over 1, 3 over 1, and 6 over 1. Then I do 1 over 2, 2 over 2, which is 1, 3 over 2, that's less row, and then 6 over 2, which gives me 3. And then you're going through all the possibilities, so then I have 3, so 3 over 1, 3 over 2, 3 over 4, and then you're going to cross off any duplicates, so you have 1, 2, 3, 6, 1/2, 1/4, 3/4, and 3/2, and the only one that has that is choice D. Choice D has all of those. The answer to the multiple choice question, or extra credit. David was born on August 30th, 2017. Our main rival is Magnolia, and our school opened in 1960. Turn to the back side. Question number 7. Make sure to show all your work and box your answers. Graph the following. Make sure to label your asymptotes and use a table. So I have f of x equals 3 over x squared. To find the vertical asymptote, green, I'm going to have to look at my denominator. I set my denominator not equal to 0, and I have to take the square root of both sides. X is equal to 0. Where is that? That's actually on my y-axis itself. My horizontal asymptotes, I'm going to look at its exponents. So there is no number here. There's no variable, so I'm going to write x to the 0. So I'm comparing 0 and 2. 0 is bigger than 2. That tells me I need to simplify. And if I simplify, because it's greater than, you'll always have y equals 0, which is right here on the x-axis itself. Then the question is, if you got that far, you got 2 points. Well, how do I get this type of a graph? I asked you to use a table because you weren't allowed to use your graphing calculators. So how do you use the table? You just pick numbers to the left and to the right of the vertical asymptote. So I picked negative 2. Negative 2 squared is 4, so you get 3/4. Negative 2, 3/4. Then you put in negative 1. Negative 1 squared is 1. 3 over 1 is 3, so negative 1, 3. There's my graph. You can do a thing on the other side as well. You got 4 points if you had some points on the table that were correct, that helped you graphed it. You have a correct graph and the vertical and horizontal asymptotes. You got 3 points if you missed one of these in here. Question number 8. Write an equation in standard form, identify the vertex. In this problem, you may have guessed that the vertex is -5, -1. But I want you to prove it. How do you do that? Well, notice how they don't give me a pair, and I'm not sure, so I'm going to use the points they gave me, which are 1, 2, 3, 4, -4, and -6. Remember, it gives me those binomials, so I'm using factored or factored form. And then I'm going to replace all of the x values with this order pair here. -3 for all my x values, and my y value will become 3. -3 plus 6 is 3. -3 plus 4 is 1. Notice how they're all multiplication here, so this becomes 3a. Divide, a equals 1. What did I do with the a equals 1? I put it back into my equation with an x-intercept of -6 and -4, and you use FOIL or the box method, and this is in standard form, y equals x squared plus 10x plus 24. To find your vertex, I added -4 and -6 together. That gives me -10, and -10 divided by 2 is -5. So my axis of symmetry is -5. If I put in -5 back into the function, I get -1, so my vertex is -5, -1. I gave you 2 points if you solve for the vertex or solve for a to be +1. An alternative solution that I got is you can use vertex form. Assume that the vertex is -5, -1, and with the same order pairs, when you put it in, you'll still get a equals 1, and then you can just FOIL and subtract 1, and you would have gotten x squared plus 10x plus 24. Question number 9. For both versions, a lot of students wasted their time using rational roots theorem. It does not say rational roots theorem. So when do you use a rational roots theorem? It's if there is no greatest common factor and you can't factor it. So let's go for the home run. Well, first, I recognize that they all have an x. If I take out a GCF of an x, I have x to the 4th minus 6x squared plus 9. Half of 4 is 2, so there is a possibility of getting a using your x box method. Well, your a value is 1, b value is -6 and 9.
Attention students and teachers, please excuse this interruption. We want to recognize the following students for participating in the PKS Reflection program this year. Students who should be conscious that 8 of them got $25 check. They're actually going to stay at the squad. We're also a lunch for today.
We're listening to these school announcements, interrupting my class time. It's like those students falling asleep or using their phones.
Patricia Rivera, Celeste Robles, and Sabrina Valeria Muñoz. Muy bien, congratulations, we'll see you in squad.
Alright, so I have a times c, which is +9. My b value is -6. Two numbers that multiply together to equal +9. Two numbers that add to be -6 are -3 and -3. So if you're using the box, let me show you that. I have -3, but pay attention, you're splitting the middle term, which is an x squared. You see that? And then your first term is an x to the 4th and a +9. So when you're breaking this up, their GCF is x squared, -3, x squared, and -3. Here, you can just solve for x. You get x is equal to 0. That's one of them. Here, you just add 3 to both sides and take the square root. Pay attention, it's x is equal to plus or minus radical 3. But you have to do it twice, so don't be lazy. So it does say the same identical thing, but do it again. And what you'll notice is that I have two radical 3's. And I have 2 negative radical 3's. And I have 1 x equals 0. So those multiplicities there tell me what's going to happen to the graph. So there's 2 negative radical 3's. That's a kiss. And at 0, it's an odd. So that means it's going to shoot through. And then at positive radical 3, it's also a kiss. So my leading coefficient is 1, so I'm going to start down and end up. And I know that because of its end behavior. End behavior, the highest degree in this problem is a 5. So x to the 5th is odd, x to the 1st is also odd, so you're going to start down and up. This value is positive, so I'm not going to change those. So when I approach square root of -3, I'm going to kiss. I'm going to shoot through at 0. And then at radical 3, positive, I'm going to have to kiss off of there and go back up. And so you got all of the points, if you have all of those. If you missed the graph, you got 3 out of 4. If you got at least some of these solutions, I may have given you 2 points. Question number 10. Write a polynomial function of minimum degree in standard form with real coefficients whose zeros are 1. So this is 1, 0. And -2i. So here I have x minus 1. And then if you put that back in there, you have -2i, but its conjugate is +2i. So a lot of students were kind of stuck on that, so you could do something like this. So you have the reals. And then you also have the imaginary. You see that? So the conjugate of this is just positive. So we don't write 0. You could, but to recognize some of you guys were really stuck there. So then when you put those back into your binomials, I have x minus 1, distribute the negative there, x plus 2i, and x minus 2i. So if you got this far, you got 2 points. Then I multiplied these two here. So x times x, x squared, -2ix, +2ix, and -4i squared. These will cancel, and this is equal to -1. So -1 times -4 is +4x squared plus 4. And then this one here, x minus 1. So if you got this far, I gave you 3 points. Then I'm just going to multiply this binomial times the binomial. That becomes x to the 3rd, 4x, -x squared, and -4. And then you put these in order, x to the 3rd minus x squared plus 4x minus 4. And then that's your answer. So again, here's the partial credit. So the most common mistake is a lot of students probably wrote x plus 1. Again, if you get stuck on that, just write x equals 1. And how do you solve for 0? Well, I would have to subtract 1 from both sides, and you'll get this x minus 1 equals 0, and that becomes your parentheses with the binomial. So 16 on that side, and then 12. So hopefully you didn't lose any points for not box or answers or being sloppy. Most students who are losing points for being sloppy, a lot of times they're using pen, not pencil. And then take your time as you're doing your test. Good luck. Question? Just take a picture of it. And send it to me. Say, Mr. Ring, this is Ernesto. Please check quiz number 9, version A or B. Hi, I'm leaving right now.
I'm training the steps for the project. That was us.
Just leave it on that desk, it'll be fine.